Hi everyone. Let's have a discussion on the second part in the second module, that is capacitance of transmission line. Already we have studied inductance of transmission line, that is first part. In the second module, that is parameter of the transmission line. Same of the derivations whatever are done in the inductance, we are going to do here also capacitance topic. Okay. Let's see the first topic: electric field intensity due to infinite line charge or electric field of a long state conductor. This derivation already studied in the field theory subject, right? So here I am considering a long straight conductor. Okay, long straight conductor of a radius r placed in a uniform medium as shown here. Here as a dielectric medium, the flux density expressed as the capital D at the radius r meters from the conductor can be obtained by assuming a cylindrical surface concentric with a conductor and r meter radius. Okay. As all the parts of the surface are at the same distance here from the conductor, having a uniformly distributed charge on the cylindrical surface of the conductor. Okay. The flux density on the surface, that is capital D, is equal to the flux leaving from the conductor per meter length, that is divided by the surface area in an axial length L. Here I am taking length of the conductor L is equal to 1 meter. Okay. See here the flux density D is equal to Q divided by surface area, that is 2 pi r into length L is equal to 1 meter. D is equal to Q divided by 2 pi r. Okay, coulomb per meter. So from this D express E, you know the relation between D and E. D is equal to epsilon into E. This derivation you have done in the field theory subject. Therefore, E is equal to D divided by epsilon. That is Q divided by 2 pi epsilon into R. Potential difference between two points due to line charge. If you take the potential at any point, is defined as the work done in moving the unit positive charge from infinity to the required point. Okay, if 2 points, if you can say P1 and P2 are at a distance D1 and D2 from the charge, potential is equal to, can express minus Q integration of, that is throughout the whole surface, integration Q divided by 2 pi epsilon r dr with respect to r radius. Okay, put here limits, you will get the d2 divided by d1. Here minus sign is there, take it minus sign here, you will get d1 by d2, getting Q divided by 2 pi epsilon naught from d1 to d2. Put limits d2 divided by d1 here, but minus sign is here, take it inside. Minus means take this reverse order, that is d1 by d2. So this is also same and this is also same. Now change here, d2 by d1 into minus means d1 by d2. Negative sign unit charge is moved, that is against to the field. It is moved against to the field. This negative sign indicates. Next, from the figure here I am showing, we consider a long straight wire carrying a positive charge Q coulomb per meter. Consider 2 points here. You can say that P1 and here is P2. P1 is at a D1 distance, P2 is at a D2 distance. Okay. Next, if you want to move a charge from P2 to P1, work done on the positive charge here. P1 is at a higher potential than the P2. If the charge moves from P1 to P2, it expends energy, which is nothing but voltage drop from P1 to P2. The path followed does not affect the potential difference. Hence, in order to find the voltage drop from P1 to P2, obtain the voltage difference between, that is voltage between equipotential surfaces, we can express V12, D1 to D2, 1 to 2. Here indicates from 1 to 2. Okay, E into dx, you know this relation. V is equal to E dot dx in the previous, that is in the third module we discussed about this, right? Then put the limit, we have d1 to d2. Okay, 1 by r ln of, that is d2 by d1. Same whatever previously expressed with this equation. Okay. Next, the capacitance of single phase line. See, capacitance between two conductors of a two-wire line is nothing but a charge on the conductors per unit of potential difference between them. So that we can express capacitance C is equal to Q divided by V. Charge of that conductor divided by potential between the two. Q divided by V is equal to C. Right. Here consider a single phase overhead transmission line consisting of two conductors, say conductor A and conductor B, which are separated by a distance capital D. Air as dielectric medium between them. Okay, the charges on each conductors are plus Q charges on conductor A and minus Q on this conductor B. The voltage VAB between two conductors can be obtained by finding the potential difference between the two conductors of the line. First, let us find the voltage drop due to plus Q on a conductor A, and then finding the voltage drop due to charge minus Q on the conductor B. Then by using the principle of superposition, the voltage drop between the conductor A and B is obtained by adding the voltage drops caused by each charge on a conductor A and B. Therefore, voltage drop VAB is equal to VAB due to plus Q charge plus VAB due to minus Q charge. Remember this equation, you can refer this equation for the next derivations. Okay, here Q divided V is equal to Q divided by 2 pi epsilon ln distance between them divided by radius. Okay, previously I discussed that this distance, second distance by first distance. Okay, therefore here the second distance means distance between them divided by radius of the conductor A, plus due to minus Q charge ln of RB divided by D. The reverse of this you have to take, or else if you don't consider the sign of the charge, if you consider only magnitude, then you can write here capital D divided by radius of that conductor, second conductor B. Okay. Otherwise, you can write with sign. You can take second distance by radius by second distance. Reverse order of this first one. Okay, getting next. Okay, next take it common here. Then ln of this divided by this minus sign is there divided by. Okay, next C is equal to Q divided by V. Write the capacitance of that. CAB is equal to, therefore RA and RB radius of conductor A and B is equal to radius R, common I have take. Therefore here R square D square by R square will get D by R whole square you have to take. This is whole square you have to take here 2 ln of D divided by R. Okay, so CAB is equal to 2 will get cancelled here, pi epsilon divided by ln of D divided by R farad per meter. Okay. Next, potential difference between two conductors in a group of conductors. Okay, before we have taken only two conductors here, more than the two of the conductors, that is n number of the conductors, how to write the potential difference. Okay, consider a group of n parallel conductors. Assume that sum of the charges is 0. It is assumed that distance between conductors are large compared to radius of the conductor. Therefore, potential difference between conductor 1 and 2 due to charge on conductor 1. See here, charge 1 is reference, charge 2, charge 3, distance between them we are writing from 1 to 2, that is from first charge, 1 to 2, 1 to 3, 1 to 4, 1 to n numbers. Okay, potential difference between 1 and 2 due to first charge. Okay, Q divided by 2 pi epsilon, that is a common. Okay, ln of D, ln of distance between them is D12 divided by radius of the first conductor. Okay. Next, if you take the potential due to second charge, reverse of that. Okay. Radius divided by distance. Next, potential between V1 and 2 due to third charge. This is the third charge, right? Due to third charge, what is the difference between the 1 and 2? Okay. 1 and 2, that Q divided by 2 pi is common. Ln of distance how to take? Second distance by first distance. Okay, 1 to 2. 1 to 2 means which is the second distance here? 1 to 3 or 2 to 3 here? See, due to third charge, potential on between 1 and 2. So you take distance from 1 to 3 and 2 to 3. Which is the first here? That is, see, V1 to 2, 1 to 2 means here second one is what? 2. Okay, here first one is 1. Okay, second distance of two conductors between 2 and third conductor, and first distance of 1 and 3 conductor, getting that is 2 3 divided by 1 3. Due to Q3 charge, here due to Q3 charge, V1 to 2, 1 to 2 means this is the second one, this is the first one. Therefore, second distance is 2 to 3 and 1 to 3. Okay. Next, similarly, between potential between 1 and 2 is due to charge 4 is D to 4 divided by D 1 to 4, right? So total. Similarly, all conductors for n conductor potential is expressed like this. Okay, adding all potentials due to all charges on a potential between 1 and 2 due to all charges. Next.